Welcome to Easy Math TV. We have another video here in our statistics series on inference. We're just going to do one more example on inference of a mean, and this one is about body temperature. So let's read the question. It is commonly believed that the mean body temperature of a healthy adult is 98.6 degrees Fahrenheit. You are not entirely convinced. So you are a researcher and you're not convinced that that is true. You believe that it is not 98.6 degrees Fahrenheit. You collected data using 39 healthy people and found that they had a mean body temperature of 98.22 degrees Fahrenheit with a standard deviation of 1.13. Use alpha, there's your Greek letter alpha there, that's our significance level. Alpha equals 0.05, significance level, to test the claim that the mean body temperature of a healthy adult is not, in fact, 98.6 degrees Fahrenheit. So the first thing we're going to do is to identify the null and the alternate hypotheses. So the null, this is about a mean, so the null is always mu equals, and that is that's the value that we're testing against. So we are testing against the true mean of 98.6. We believe that it's not that. We don't know which side of it is, so we have to say mu is not equal to 98.6. I mean, in fact, we could say mu is less than, since the sample had a value that was less than 98.6, but we need to make our alternate hypothesis match the claim. So now the question that's being asked is, and this is a little different from our previous video, it says, what type of hypothesis test should you conduct? Left, right, or two-tailed? So that is based on our alternate hypothesis. If the alternate hypothesis had been a less than, it would be left-tailed. And a good mnemonic device or memory device there is left and less. Left goes with less, which means that right goes with greater. So left is less, right is greater, and because we have a not equal to, it is a two-tailed test. So a two-tailed test means not equal to. Identify the appropriate significance level. So that is our alpha equals 0.05. So I'm just going to type that in. And in a moment, we're going to be using StatCrunch to calculate our test statistic. Okay, so let's jot some numbers down here. I'm going to copy some of these numbers. So we have a sample size of 39. Our mean from our sample, so sample mean is 98.22. And sample standard deviation, which is S, is 1.13. Okay, those are the three things that we're going to need to type in when we go into StatCrunch. So let's flip over to that. And again, we don't know what the population standard deviation is, so we're going to go to the stat menu and we're doing T-stats again. This time we have one sample with summary. We do not have the actual data. One sample with summary. So our sample mean, I'm just copying from that document that I typed onto, so 98.22. Sample standard deviation was 1.13. The sample size was 39. And our hypothesis is the true mean was 98.6 versus mu not equal to 98.6. And I'm going to go ahead and show the critical value just in case we need it. And our significance level is 0.05. So let's go ahead and hit compute. And these are all the values that are going to help us make our decision. So let's go back over here. Calculate your test statistics. So test statistic is our capital T stat there. So let's just copy and paste that. We need to be careful when we copy and paste because you can accidentally get too many, it does say to round to 3 decimal places. So um, let's go, so that would be negative 2.100. Calculate the p-value, and this time we want to round to 4 decimal places. So let's go. Our p-value is exactly 0.0424. And again, our p-value is in fact less than alpha. Let's pretend for a moment that it hadn't been, okay? Um, because we didn't really talk about that in one of my videos here. So I want to discuss what we would do if the p-value in fact was a little bit larger. So suppose that our p-value is 0.053 or 2. Okay, 0.052. So the p-value is larger than alpha. And when that happens, it's not it so the opposite of rejecting the null hypothesis is failing to reject the null hypothesis. So we are going to fail to reject the null hypothesis if the p-value in fact had been larger than alpha. Fail to reject the null hypothesis. It's not that you're going to accept it. We're just going to fail to reject it. It's very critical that we phrase it in the correct way. But that is not what we have here. We have a p-value of 0.0424, which is in fact less than alpha. So since the p-value is less than alpha, we are going to reject the null hypothesis. So we reject the null hypothesis since the p-value is less than the significance level. So our summary statement, select the statement below that best represents the conclusion that can be made. Remember, when we reject the null hypothesis, that means that we have sufficient evidence. So we have sufficient evidence to support the claim that the mean body temperature of a healthy adult is not in fact 98.6 degrees Fahrenheit. So our options would have been between this first statement here and the third statement. The first statement is wrong because that says sufficient evidence to warrant rejection of the claim that the mean body temperature of a healthy adult is not 98.6. But we're not rejecting that. We're rejecting that it is 98.6 degrees. Um, so our sample data do in fact support that claim, which is in line with the alternate hypothesis that the mean body temperature of a healthy adult is not 98.6 degrees Fahrenheit. So this is the hardest part of these problems. The most difficult part of a hypothesis test is being able to write your conclusion at the end using the correct terminology. But with a little bit of practice, you will get used to it and you'll get better at it as you go. Like, subscribe, comment down below. Um, Make sure you share these videos with other people that you think might find them useful, and I'll see you in the next video.